beats. So this beats comes in waves. So practically we will see the sound of beats in ambulance vehicle. In ambulance vehicle, that is siren sound which is coming from that ambulance. So sound will come to maximum like this. So sound will reach to maximum and reach to minimum like this and going to maximum and minimum like this. So sound will be like this. That is known as beats. Maximum and reaching minimum, maximum, minimum. So that is the beat sound which we can see in this ambulance vehicle and police vehicles also. Police vehicles. So here also we can see this which are sound of beats, right? So how it is possible to get this maximum and minimum? So some conditions are there here. So we'll study those conditions and we will get a standard equation for this beats, right? Okay. So the conditions are, first you have to consider we have to consider two waves. First one is two waves we have to consider, right? So what is the another condition? Amplitude should be same. Amplitude is same. So this is the condition. Means you have to take the wave such that two waves you have to consider such that this amplitude is same. This amplitude from the mean position to the maximum peak. So this value, this is A, means this should be A. This value should be equal, this distance. Suppose if you are taking 1 meter, means this should be 1 meter, 2 meters means 2 meters. So the two waves should have same amplitude. Next, nearly same frequency, not equal frequency, but nearly same frequency. So this wave should have a frequency, that is value should be nearly equal. Suppose if you take here like this, so this is, if you are considering like this, so suppose this is t equal 1 second. T equal 1 second. So in 1 second, how many waves passed here? This is 1.5 wave. Right here, this is only nearly 1 wave. So 1.5 wave means we are frequency is 1.5 hertz here. This is 1 hertz here, frequency. So it is such that it is nearly equal, means it should be nearly 1.4 or 1.3 like that. So frequency should be nearly equal, right? And fourth one is they should travel in same direction. Opposite direction will get stationary waves, same direction. So both waves should travel in same direction. If these four conditions, if we take, then we can get the beats if we superimpose the two waves. Means combining these two waves having same amplitude and nearly same frequency and traveling in same direction. If we superimpose means adding these two waves, we can get the beats. So beats is like this, minimum, maximum. So if you superimpose these two, we will get a combination like this. This is minimum, this is maximum, and so on. So this is beats. So to get beats, you have to consider these conditions, right? So here I will take two waves here, y equal to a cos omega 1t, this is y1, y2 equal to a cos omega 2t. So but the condition is you have to consider two waves. That is first condition, I consider two waves here. What is second condition? Amplitude is same. Here I took a and a. These values I didn't change. A1 and A2 I didn't take, as the condition is amplitude should be same. And what is omega? Omega equal to pi f. That is frequency. No? So frequency should be nearly equal, not equal. That's why I took omega 1 and omega 2. If the condition is equal frequency means I have to take omega and omega. But nearly means that's why I took omega 1, omega 2. Right? So both are traveling in the same direction. Now I am superimposing these two waves. That is y equal to y1 plus y2. Right? If I add these two waves, this is a cos omega 1t plus a cos omega 2t. So a into this cos c plus cos d is 2 cos c plus d by 2 formula in the mathematics, cos c plus cos d is 2 cos c plus d by 2 cos c minus d by 2. This is standard formula for cos c plus cos d, right? Now this is a to a, this one 2 into a, cos of omega 1 plus omega 2 into t by 2 is cos of omega 1 minus omega 2 into t by 2. Now for the bits I have to get the minimum and maximum now. So for that one what I have to see, I have to, this is superimposing equation. So this is maximum because plus sign is there, this minus sign is there. So for this one we have to maximize to get the maximum wave here, and this one only we have to minimize so that we get the minimum. So you have to consider this one only in the superimposing way. You consider this one and equate to maximum and minimum so that we can get the condition for the bits. So I am considering only this part, that is cos of omega 1 minus omega t by 2 cos of omega 1 minus omega 2 into t by 2. So this maximum, this minimum. Okay. For maximum we have to consider this part only, right? So for maximum, what is the condition? Your cos should be plus or minus 1, means your general value is n pi, this value 2n plus 1 pi by 2 for minimum. So those are the standard conditions. So that you have to know, right? So if you want that, you can refer my video, Basics of Mathematics and Physics. So you can see that conditions there. So this one is for maximum, omega 1 minus omega 2 into t by 2 equal to cos n pi. So putting the values of n equal to 0, 1, 2, 3, we will get the maximum values here. So if you equate this one, cos of omega 1 minus omega 2 t by 2 equal to cos of, this cos of 2n plus 1 pi by 2, right? So this is 2, so this is 2. And by putting n equal to 0, 1, 2, you will get the minimum values, right? N equal to 0, cos 0 is 1, n equal to 1, cos pi, minus 1. So you are getting 1, minus 1 and so on. So your cos value, maximum value is 1 and this is minus 1. So these are the maximum values, right? Okay. So if you put n equal to 0, pi by 2, cos 90 is 0 now. That is the minimum value you are getting. So by putting n value, you can see this value. N equal to 0, cos 0 is 1, maximum value. N equal to 0, cos 90 is 0, minimum value. So for minimum, this is the general, 2n plus 1 pi by 2. For maximum, this is the condition pi. So if you cancel this cos, your omega 1 minus omega 2 into t by 2 equal to n pi. Right? Here, omega 1 minus omega 2 t by 2 equal to 2n plus 1 into pi by 2. Okay. Now, what is omega 1? 2 pi f1 minus 2 pi f2 into t by 2 equal to n pi. Here also 2 pi f1, 2 pi f2 into t by 2 equal to 2n plus 1 into pi by 2. So I am writing omega equal to 2 pi f, right? Now, by taking this, you can get the condition here, right? So what is the condition here? This one, you can cancel this 2 and pi here, but you can cancel this pi and 2 here. So your t value will be here n by f1 minus f2 for maximum. Yes, from this one here t equal to, you will get the condition for this one as 2n plus 1 by 2 into f1 minus f2. This one from this. Okay. Now by putting the values here, n equal to 0, 1, 2, plus n equal to 0, 1, 2, you can get the time interval between the which are two successive beats here. By putting n equal to this 0, by putting 1, this is 1 by f1 minus f2. Okay. Here also t equal to 0 means this one is 0. No. What is the value? 1 by 1 by 2 into, by putting n equal to this 1 by 2 into f1 minus f2. By putting 1 here, 2 plus 1, 3 by 2. 3 by 2 into f1 minus f2. Okay, you can put other values to get the values. Now what is the time interval between two successive bits? You have to subtract this one. So time interval between two successive bits is given by 1 by f1 minus f2 minus 0 is 1 by f1 minus f2. Here also time interval between two successive bits will be same. 3 by 2 minus half is how much? 3 minus 1 only, 1 by f1 minus f2. So this is the time interval between two successive bits. So what is the frequency now? Frequency reciprocal of time, right? So beat frequency is given by beat frequency. Beat frequency is given by reciprocal of this one is f1 minus f2. So this is the formula for beat frequency. Time interval is 1 by f1 minus time is 1 by f1 minus f2. Okay, so this is regarding bits. Thank you.